Hello and good day. We are going to be correcting CO11 in pre-algebra order of operations before moving on to CO12, where we're really going to explore the E and the R of PERMDAS, exponents and roots. Some of the expressions that we had on CO11 included powers, but we didn't have any roots, and so today we're going to kind of look at some expressions that would. So I will put the answers up here on the board, and if you want to stop and talk about any of them, please let me know. So first row, we did this one together. 26 is the solution to that. Next one is 18. 4 squared would be 16, then add 2 to get 18. This third one here, I don't think we did it together, but it's one of those situations where we come across when the order of operations isn't followed exactly, right? You would do parentheses first, and that would leave you with 20 divided by 4, and then in parentheses still have 5. Maybe we did do this together. But anyway, since all we have left is multiplication and division, we would not do that multiplication first. Okay? We would work from left to right. So you should take 20 divided by 4 next to get 5, and then 5 times 5, 25 would be the answer to that one. Next one is 864, and then 25 to round out that first row. Any you want to go over in more detail from that first row? Okay. Second row, start out with 20. The next one we did together, negative 40. And then we have positive 2. And then finally 5. Any thoughts on those questions? Okay. Then this bottom section here, I'll scroll down so we can see a little bit better. But this bottom section, you needed to insert parentheses, where necessary, so that the expression equals 30. Because as they're written right now, they equal all sorts of things, right? But we need to add parentheses to change the order of the solving process as it's written to make each one equal 30. So the first one we did together. We put parentheses around the 5 plus 5 because originally you'd multiply first. 5 times 3 is 15 plus 5 is 20. But by putting parentheses, now we're adding 5 and 5 first to get 10. And 10 times 3 gives us 30. Where did you put them in the next one? Who would like to share? Where did you put your parentheses in the next one? Yeah, Annika. Around the 3 and 2? Well, we would do that first anyway, even if there weren't parentheses written, because multiplication would come before any subtraction. And if we do that, then we've got 20 minus 2 minus 6, which doesn't equal 30. Okay, so around the 3 and the 2, not necessary because we would multiply first anyway, but it doesn't make the equation equal 30. Maggie, where'd you put yours? Around the 20 and the 3. Okay, now instead of multiplying first, now we're going to be doing the subtraction first. And 20 minus 2 minus 3 is 15. And then we multiply that 15 by 2 to make it equal 30. Right? So your goal for all of these is to make them equal 30. Third one, where'd you stick them? Where'd you put your parentheses here? Yeah? Around the 4 and the 2. That exponent actually gets left outside, right? Because doing that 4 and 2 first gives us 6, which then we square that to get 36, and then subtract 6 from that. That's how we get to 30. Yep, so that exponent needs to stay on the outside so that we get that 6 for what we are squaring there. Next one, where'd you put them? Anyone want to share? This would actually require 2 sets, right? Maggie? The first one around the 11 minus 5, and the second one around the 1 plus 4. Because doing each of those first, 11 minus 5 is 6, 1 plus 4 is 5. 6 times 5 is how we get to 30. So 2 sets of parentheses were required here to get the difference in the sum first, and then multiply those together. And the last one, where'd you put them here? Okay. Close. The 36 and the 12, actually. Okay. 7 times 12 is 84. And then we add 36 to that. That gives us 120. And then 120 divided by 4 equals 30. Okay. If we did have them around the 36 and the 7, that would give us 43. We have to add that first. Then we have to multiply 43 by 12, which is like 400 or 500 something. And then divide that by 4. We're not going to get down to 30. So the key was to get around the 36 and the 12. We would still multiply first within the parentheses to get 84, then plus 36, 120 divided by 4. Yeah?
Would 7 and 12 work?
7 and 12. Okay, so putting them here, parentheses first, right? We'd have to multiply there. So we'd have 36 plus 84 divided by 4. The 84 coming from the 7 times 12. What would we have to do next then? The way it's written here, 36 plus 84 divided by 4. What would come next? We have addition, we have division. What comes first? Pierce?
It's division.
Division. 84 divided by 4 is 21. So then we have 36 plus 21, which doesn't get us to 30. So around the 7 and the 12 would not work because we would end up dividing before adding. But that 36 is kind of key. We need that 36 added to the 7 times 12 to get something that when we divide by 4, it gets us down to 30. Okay? So I believe that is the only option here. Anything else with order of operations? Yeah, Sasha.
For the bottom one, the second one, can you also do 20 and 2?
Just the 20 and 2. So if we did that, just the 20 and 2, okay, so we would do that first, right? So 20 minus 2 is 18, and then we'd be subtracting 3 times 2. So between subtraction and multiplication, the multiplication would have to come next, and we would get 18 minus 6, which gives us 12, but not 30. So we do need that around the 3 also to have all subtraction happen first to get that 15, and then double that to get 30. Okay. Yeah, not really easy. Take a look at it and figure out, okay, the way it's written doesn't work to get 30. How do I reorder these? So there will be one like I said, there will be one like this on your test where you'll need to add parentheses to make it equal what you want it to, or what I want it to, I guess. Okay. Anything else? All right, onward and forward we go to CO12, where we really get into exponents and roots. You spent grades kindergarten through probably 4th grade just doing addition, subtraction, multiplication, division. Maybe you got some exponents in 5th grade, maybe not. Certainly last year in 6th, but your work with radicals is probably the least coverage thus far. So CO12 is dedicated to exponents and radicals, and you see down here you've got some expressions, still following the order of operations, but all of them include an exponent and or radical. And so that's going to be our focus today. So these charts, since you cannot use a calculator on this portion of the test, will be helpful. Okay. We're going to write down all of the powers and all of the roots that you will need to know for the test. Copy this on a help sheet so you have it. So even without a calculator, you've got this guide to help you. So for exponents, okay, we're going to focus on squaring. So as I fill this in, recommend you fill it in as well. 1 squared is 1, right? It means 1 times 1. An exponent is, an exponent is used to show repeated multiplying, right? Multiplication is repeated addition. 4, you don't have to write this down, but 4 times 3 is either 4 plus 4 plus 4, just 3 4s added together, or 3 plus 3 plus 3 plus 3, 4 3s added together. Both of those equal 12. So multiplication was kind of invented, so to speak, as a way to show repeated addition. Okay, exponents were invented, so to speak, to show that we are repeatedly multiplying something times itself. So 2 squared, which is 2 times 2, gives us 4. 3 squared, 3 times 3, gives us 9. Okay, 4 squared is 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. And this is where most of your multiplication tables probably ran out that you had in K to 5. 12 squared, 144. We're going to go all the way up to 16 squared. So 13 squared. It's the highway that runs right by St. Vincent. A lot of you probably drive in the morning. Afternoon. 169. 14 squared. 196. 15 squared. 225. And 16 squared. Good. 256. Okay. So this should definitely be a section that gets down on a help sheet and comes in for the test, so that you have these as a guide, right? And then square roots, like we talked about in PermDAS, the E and the R, okay, they're part of the same group, right? Because they're opposite operations. We're going to talk about that. Exponents undo radicals. So for our square roots section, we're going to start with the root of 1, okay? And the root of 1 is just 1. The root of 4 is 2. And the root of 9 is 3, right? So if you look across from one table to the next here, 3 squared is 9. The root of 9 equals 3. Tell me how exponents and radicals are opposite operations here. What do I mean when I say that one undoes the other? Yeah, Connor.
The opposite of the exponents is 4, but then the 4 is the rational number, but the opposite of the rational number is the 2.
Okay, so what makes operations opposite is that you're able to get back where you started from, right? If we start, and you don't have to write this down, this is kind of separate here, but if we start with the number 9 and we add 4, how do we get back to 9? Subtract 4, right? 9 plus 4 minus 4, that plus 4 minus 4, they kind of cancel each other out because they're opposites. We did something, then we undid it, okay? If we start with 6 and we multiply it by 3, how do we get back to 6 again? Divide by 3, right? If we triple 6 or multiply it by 3, to undo that, we would divide by 3, and we get back to 6. So for exponents and roots, using this 3 here, if we square 3 to get 9, how do we get back to 3? If we square 3, 3 squared equals 9. From 9, how do we get back to 3? Divide, or since we're talking about exponents and roots, we would root it, right? If we start with 3 and we square it to get to 9, to get back to 3, we would take the square root of 9, which equals 3. Because the definition of a root is what number times itself equals, in this case, 9. Okay? That's how they are opposites. It's very easy to see because you're familiar with it. Add 4 and subtract 4, that's opposite. Multiply 3 divided by 3, those are opposites. The same relationship happens here. Square 3 to get 9, root that 9, we're going to get back to 3 again. So the root of 16, what number times itself is 16? 4. The root of 25 is 5. The root of 36, 6. The root of 49, 7. The root of 64, 8. And you can definitely see the relationship here as we go through our powers table, right? 8 squared is 64. The root of 64 is 8. 9 squared is 81. So the root of 81 is 9. 10 squared is 100. So the root of 100 is 10. And we can follow that relationship all the way to the end. All the way down to the root of 256, which is 16. Just like 16 squared is 256. Okay. Questions on it? Any of this? No? Give it a couple more seconds to get these notes down. And if you are done with the notes, feel free to go down to that bottom section to where it's really very similar setup as the last page, only now, like I said, we'll deal with a lot of roots and powers just to get kind of used to those things there. So you will not be able to use a calculator on this section of the test, which is why these 2 charts are going to be so helpful. So if you use a calculator on your homework, I strongly encourage that you use it just to check your answer rather than find the answer. Okay? Use it to check your answer rather than find the answer. Do you all know how to input an exponent and a root in your calculators? Have we talked about that yet? Okay. So if you kind of hold up your calculator, most of you probably have a calculator that looks like Connor's. It might be blue or navy blue or green or pink or red or whatever. But on those calculators, your squared key is, I think, immediately to the left of the 7. Is that right? Yeah. So if you find the 7, immediately to the left of that is a button that says x squared. Okay, that is your squaring key, right? So if you wanted to figure out what 11 squared is, you would type 11 and then press that button. It would give you the little 2 up there, and then press enter, and you should get 121. If you've got this kind of calculator, try that now. Take 11 squared, make sure that you can get 121. First push 11, and then that x squared button, you get the little 2. Push enter, and you should get 121. Everyone good? Okay. The root symbol is actually that same button But notice how the root symbol is on the calculator. It's not on the button, but it's on the actual calculator, and it's above the x squared key. To get something that is above a key like that, you need to go up in the top left corner of your calculator and find the button that says second. That's kind of like your shift key. You know how on a computer, if you want the symbols above the numbers, you have to press shift first, you know? That's kind of like your shift key. So to find the root of 121, what you would do is you would push the second button first, then that x squared button again, but instead of the little 2, now you're going to get something that looks like this, the root symbol with a parenthesis provided. But you have to press that second button first. Okay, so second, then your x squared key, and in your display you'll get this root symbol. Then you'll type in 121, close your parentheses, and hitting enter should give you 11. Any issues with that? Sasha? So the second is way up in the top left. Yep. Top left corner of your calculator, that second function button. You've got a different one. I'll come to you once I'm done recording. Okay. Anybody not able to get 11 by taking the root of 121? Again, second function, x squared button to get that root symbol, 121, close your parentheses, enter. Now I'm showing you this now, not like I said, so you can find the answer using your calculators, because you will not be able to use this on the test. But I do want you to have the opportunity to check your answers once you do them on the page. But you need to know how to use your calculator, otherwise it's not going to do you very much good. Okay, just like my dad gives me a new tool for Christmas every single year, but I have no idea how to use them. So I have a garage full of tools, and all I really use is a hammer and a screwdriver and tape. And hopefully I can fix it. All right. So tools are great, but you got to know how to use them. All right. So looking at a couple of them down here, is there one from this section that you would like to do together? One that looks particularly fun, and I can guess which one you're going to pick. Let's not do the last one yet. Let's do one before that first. Just kind of get the process here. So Pierce, which one would you like to do?
The 36 over 1.
The third one there, the root of 36 over 121. So the nice thing about roots of fractions, what do we know we can do with fractions? We can turn it into a decimal. 36 1/21 is going to be kind of a nasty one, though. What else can we do with fractions? It means division. Okay. We've also talked about how we can simplify fractions, but there's something cool we can also do when we're taking the root of a fraction. Instead of the root of the entire fraction, the way it's written here, we can split this up to be the root of the numerator over the root of the denominator. So it becomes root 36 over root 21. Okay, those are equivalent expressions. The root of a fraction, the root of 36 1/21 can be rewritten to be the root of the numerator divided by the root of the denominator. And do we know what the root of 36 is? 6. Do we know what the root of 121 is? 11. So that expression equals 6/11. Okay. That expression equals 6/11. Now, how would you use your calculator to check that? Okay, I'll walk you through the steps. First, you want to push your second button. Then you want to push the x squared button, not because you want to take the power, but because you want that root symbol above it. That's going to give you the root symbol with that first parenthesis. Then you want to type in 36 divided by 121 and close your parentheses and then hit enter. Okay, so second function first, then your x squared button to get that root symbol. 36 divided by 121, close your parentheses and hit enter. And you get a nasty decimal, right? Actually, not that bad probably, but what is your decimal answer? Sorry?
It was like 4.545.
It wouldn't be 4 point. We're not going to get a whole answer here to where it's 4 holes. Gigi? 0.54 repeating. That sounds about right. So yeah, so it was close. Okay, so we get 0.54 repeating. Now go to your answer. Just take 6 divided by 11. No root, no anything. We've taken the root. We just have 6 elevenths. 6 divided by 11 should give you the same decimal, right? That's how you know that you've done it correctly. If the original expression and your answer are the same thing, the same decimal, that means they're equivalent expressions, which means you've done it right. Okay? Pick another one. Not the last one yet that you want to do together. Another one of the remaining 7. Here's.
The second to last one.
Second to last one. 1 to the 8th times 3 to the 4th plus the root of 64. So order of operations here, right? We've got exponents, we've got roots, we've got multiplication, we've got addition. Whew. What do we do first? What do we do first? In PERMDAS, of the operations that this particular expression has, which it's got multiplication, it's got addition, it's got exponents, and it has roots, where do we start? Okay, here are different levels here. Where do we start? We start with the exponents and the roots. Okay, we're not going to multiply yet. We have to do the exponents and the roots first. They're in a whole nother level than multiplying is. So we're going to start by taking 1 to the 8th, which is what? 1, right? It just means 1 times 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 1, 8 times. And then we're multiplying that by 3 to the 4th. What's 3 to the 4th? 3 times 3 times 3 times 3. Sasha? Not 12. That'd be 3 plus 3 plus 3 plus 3 plus 3, but we're multiplying here. 3 times 3 times 3 times 3. Aiden?
81.
81. Did you do that without a calculator?
Yeah.
How?
Mental math.
Mental math? What did you do?
3 times 3 equals 9, and then 3 times 3 equals 9, and 9 times 9 is 81.
Very good, very good. Yeah, some of these, sometimes kids look at me like, how am I supposed to figure this out without a calculator? Like you expect me to, but if you kind of break it into parts, especially with powers, Aiden recognized that, well, 3 times 3 is 9. The other 3 times 3 is also 9. And I might not know what 3 times 3 times 3 times 3 is off the top of my head, but I certainly know what 9 times 9 is, right? That's a basic fact. And so you can get to 81 pretty easily that way. So anyway, 3 to the 4th is 81. Now we're adding to that the root of 64. Root of 64 is 8. And so our expression becomes 1 times 81 plus 8. We've taken care of all the exponents and the roots first. Okay. Now we go to the next level. We've got multiplication and addition. We're going to have to multiply next. 1 times 81 is 81. Taking care of that. And now we can go to the adding, and we get 89. Okay? So as you're going through these, make sure you are following that order of operations. Like the first one in the second row, you're going to have to square 15, square 14, then square 13. Get all those products first before you subtract or you add, right? Order of operations. All right, we are running a little bit low on time, so let's get to that last one there. The fact that we did the root of 36 over 121 should help a little bit here, because what can I do with the roots of those fractions? instead of the root of 149ths, what's my little trick that I can do to make this more manageable? John? I'm not going to turn it into a mixed number here, but look at what we did with that root of 36 121st. Gigi? Right, I'm going to split this up. I'm going to take the root of my numerator, which I know what the root of 100 is, and divide that by the root of my denominator, 49. That's manageable, right? And then my second fraction, I got the same thing. I can break that up, the root of 25 over the root of 9. So once you find those roots, you'll see that you get fractions, and then you're adding those fractions. So now you got to kind of go back to P09 and think about, adding fractions, common denominators, do that whole thing, right? And then we're multiplying that sum by the root of 4, which is 2. So take the roots to get fractions like we did here, right? Our answer here, 6/11ths. Take the roots of those to get your fractions, add them together, and then you're going to be multiplying that sum by 2. I'm going to let you do the rest on your own for that one, but that should get you started. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this? All right. Homework is to finish it actually for Thursday because tomorrow is going to be your retake day. So homework for Thursday, that is How You Math.